In this video, we'll cover the fundamentals of MLOps. Today, our focus is on understanding environments and assets in machine learning projects. So let's get started by talking about the different environments commonly used in machine learning projects. Typically, we see three primary environments: dev, stage, and prod. Let's start with the development environment, or dev. This environment is open for use by most team members, providing easy access for data scientists and engineers to experiment and build models. Since dev is separate from live production, there's low risk in testing and making mistakes here. You'll often see teams working together in this environment to produce models and prototypes with minimal impact on the main system. Once development is complete, the project moves into the staging environment, also known as stage. This environment serves as a bridge between development and production, allowing us to test models more thoroughly. Fewer people have access to staging, and here we ensure that data quality aligns closely with production standards. This setup helps teams evaluate how models might perform in a live setting, giving stakeholders a chance to review and provide feedback before the model goes live. Finally, we reach the production environment, often called prod. This is where our end users interact with the application, making it a critical environment for the business. Access to production is tightly controlled using identity and access management tools like IAM in AWS to ensure only the necessary team members can make changes. Here, our focus is on maintaining the highest quality, as any issues in production directly impact the user experience. While dev, stage, and prod are common across many machine learning projects, depending on your industry or company, you might encounter additional environments. But in most cases, you'll see these three core environments. Now let's look at the assets we work with in machine learning projects. First, there's the code file. This could be a Python script or a Jupyter notebook, responsible for data transformations or other project-specific functions. These code files are typically stored in a version control repository like Git, which helps us track changes with branches for each environment. Then we have models and model artifacts. Unlike standard code, models often need to be retrained as data evolves, which means new artifacts get created. For example, say we deploy version 1 of a model, and a week later, new data arrives. We might retrain the model with this updated data, creating a new artifact. To keep track of these artifacts, we use a model registry. Regarding storage environments for data, we separate dev, stage, and production storage as well. The development storage often has temporary data that changes frequently. In staging, data quality is closer to production, with regular refreshes from the production environment, usually monthly or quarterly, depending on project requirements. And in production, data is kept up to date and reliable, serving as the foundation for real-time predictions. Now, let's take a high-level look at the CI/CD pipeline, which stands for continuous integration and continuous deployment. For our learning, we'll mainly focus on MLOps with AWS. Imagine a typical workflow. We start with code commit, which helps us monitor the project code. When we commit a code change, code build runs integration tests and other discrete tests. Next, we use Amazon SageMaker to train the model with data from storage, and the model is tracked in the SageMaker model registry. After a model is registered, we can pull the latest code into the production environment. Code build performs a final validation, and then we deploy the model. AWS services help automate much of the infrastructure setup during deployment, and the model registry provides an endpoint for other services to access the model. This same process applies to staging and production. For staging, we verify that everything works as expected before stakeholders approve the model for production. So that's an overview of a CI/CD pipeline in MLOps. Throughout our learning journey, we'll cover each of these AWS services in depth so you can set up a complete CI/CD pipeline for your machine learning projects. We'll also dive into Amazon SageMaker to better understand orchestrating the entire pipeline. In this video, we covered the fundamentals of MLOps, the environments, and the common assets used in machine learning projects. In the next video, we'll dive even deeper into machine learning operations. Thanks for watching, and I'll see you next time.